Kia ora ngā hoa. On today's video, we're going to be learning about Euler's theorem. Probably one of my favourite things in maths. It's one of those maths magic moments that'll just blow your mind. So stick around and I'll show you how it works. Okay guys, so I'm going to show you Euler's theorem. Now this is probably my favourite thing in maths, and like I said at the beginning, it's like one of those maths magic moments that you go, wow, how does it do that? Well, it's really just maths, okay? And it's one of those things that you'll be able to show it off to your parents and they'll be like, wow, how does that do that? And you'll be able to say, because it's just maths. Mr. Ashley said so. Euler's theorem basically works on the premise that the face of a platonic shape or a three-dimensional shape, so the number of faces plus the number of vertices or corners, take away the number of edges, always equals 2. Always equals 2. And so what we're going to do is we're going to do one today with just a plain old cube, because it's easy for everyone to understand, and show you how it works. So the first thing we need to do is figure out the number of faces. Now, the number of faces on a cube is easy because it's the same as a dice. How many sides does a dice have? It has 6. Okay, 6. Now, the number of vertices is the number of corners. Okay, corners on a shape. Okay, or points where two or more edges intersect. Okay. So the number of vertices on this shape is 8. So we'll count them up. Now remember that there's one hidden on the other side over here, so we'll just draw a little dot there so you know that he's hidden in our three-dimensional picture on the other side because we can't turn it around. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, we'll put them in parentheses for now, in brackets, and we need to know the number of edges that we're going to take away from this. Okay? If you're playing the home game, you already know that this is 14. So we need at least 12 over here for this to work. So let's count up the number of edges because we need to take away the number of edges. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now there's an edge down the back, running down the back here, 10, and another one that runs across. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Make sense? So 12 goes in our equation here. So if we look at Euler's theorem again, the face plus the vertices take away the edge. So basically what it's saying is 14 take away 12, okay, which is, whoopsie, 2, okay, and it works all the time. Now I'd love to show you another shape, but we'd be here all week because I love this so much I'd get all carried away and show you icosahedrons and all kinds of stuff, but it does work, okay. So what I recommend is finding some of your favorite three-dimensional shapes and trying it out with this, okay? Because it's really fun to blow your mind and go, whoa, it still equals 2, oh! Okay? But, so I would show it to your parents too, and then they might get on board too and try and stump you with a shape that you've never heard of before with like 30 sides, and it'll still work as long as they're not making up their own shapes, mum and dad. Okay? But for now, ka kite, until next time on Mr. Ashley's Place.